Welcome! You ever wonder how developers manage these huge, complex applications that are spread out all over the place? Well, a lot of the time, it really just comes down to a few super precise commands. And today, we're going to get you behind the controls of that command center.
Okay, so let's break this down with a really simple idea. Think of Kubernetes as this incredibly powerful, super smart operating system for all your stuff in the cloud. And kubectl? That's our remote control for it. It's the one tool that lets us tell this massive system exactly what to do with total precision.
All right, we've got our remote control ready to go. So what's the first mission? It's time to get our application up and running. Let's launch this thing.
So we kick things off with kubectl create deployment. Now, notice we're not just saying run this container. We're creating something called a deployment. You can think of this like hiring a dedicated manager for our application. Its whole job 24/7 is to make sure our web server is always up and running exactly the way we told it to.
You know, an application isn't much use if nobody can actually get to it, right? That's where this expose command comes in. It's the next critical step. What it does is create something called a service, which is just a stable, reliable network address. This command basically opens a door, a pathway, so the outside world can connect to our brand new web server.
Okay, so our app is deployed and we've opened the doors for business. But is everything actually working? Is the engine running like it should be? Let's pop the hood and take a look at the vitals.
I mean, this is it. This is the big question every single developer asks themselves right after they hit enter on a deploy. Did it actually work? Well, let's find out.
And that brings us to what is probably the single most used command in your entire Kubernetes toolkit, get pods. Pods are the fundamental building blocks in Kubernetes. They're where our application's containers actually live. So this command gives us that quick, high-level, is it okay, status report. It's our first port of call.
And there we go. This is exactly what we wanted to see. Look at that status column. It says running, and the ready column shows 1/1, which confirms that the container inside our pod is healthy. We have liftoff.
But let's be real for a second. It doesn't always go this smoothly. Sooner or later, you're going to have to put on your detective hat and figure out what went wrong.
So what do you do when Git pods gives you something scary looking like crash loop backoff or just a plain old error? These statuses are great at telling you that something is broken, but they don't tell you what is broken. For that, we've got to dig a little deeper.
To get all the juicy details, we use describe pod. Think of this as getting the pod's complete life story. The real clues, though, are usually hiding at the very bottom in a section called events. This gives you a play-by-play of every single thing Kubernetes tried to do to start your pod.
And here's a perfect example of what you'd see in those events. This little message tells us that Kubernetes successfully found a home for our pod on a machine called worker-node 1. Now, if there's a problem, say not enough memory on any machine, the event log is exactly where you'd see that error message.
Now, sometimes Kubernetes is doing its job perfectly, but the application inside the container is the one having a problem. To figure that out, we need to listen to what the app itself has to say. And the kubectl logs command lets us do just that. It's like peeking inside the container to see the exact output our code is producing. And bam, there it is. This is the kind of smoking gun you can find with kubectl logs. The Kubernetes event log might look totally fine, but right here, our application is literally screaming that it can't connect to the database. We just found our bug.
So our app is up, it's running, it's healthy, great. But in the real world, things change, right? Traffic goes up, we release new features, applications aren't set in stone. So let's take a look at how we manage that life cycle.
So let's say your app is a massive hit and traffic is just flooding in. What do? Well, it's actually super simple. We use the scale command. With just this one line, we're telling our deployment manager, hey, I need more power, and it'll increase the number of running copies or replicas to handle all that new load.
And the result is pretty much instant. We just went from 1 copy to 5. We simply declared that we wanted 5, and Kubernetes immediately went to work making it a reality. That's the real power of this stuff right there.
Oh man, it happens to every single one of us. You push out a new version of your code and suddenly everything is broken. You've got a bad update out in the wild. What's the fastest way to fix it?
I'd like to introduce you to your new best friend, the emergency undo button. The rollout undo command tells Kubernetes to immediately, and I mean immediately, revert the deployment back to the previous version that was working. It is an unbelievably powerful way to recover from a disaster in just seconds.
Okay, so we've launched our app, we've debugged it, we've scaled it up, and we even fixed the bad update. Now the project is over. It's time to be a good citizen and clean up all of our resources.
And this is where using that deployment right at the beginning really pays off. Cleaning up is so simple. A single delete deployment command tells that manager we hired to go ahead and terminate all the pods, remove the network service, and just erase every single piece related to it. One command, and poof, it's all gone.
I want you to just stop and think about what we just did. With just a handful of pretty simple, easy-to-read commands, you orchestrated the entire lifecycle of an application. You were the conductor of a complex cloud orchestra. So the only question left is, with this kind of power at your fingertips, what are you going to command next?